Good day everyone. Today we will be discussing about comparing the sample mean and population mean in a small sample size. Last meeting we discussed about comparing the sample and population mean in a large sample size. So what's the difference between the two? Last meeting we discussed about a large sample size wherein we deal on z value. Today, since we deal on the small sample size, we're going to deal with the computed t value. The t-test of one sample mean is used to compare sample mean and population mean in a small sample size. We use the z-score formula for sample means because we are dealing with sample means. Thus, by the central limit theorem, we have t is equal to x bar minus mu all over the sigma sub x bar, where sigma sub x bar is equal to s over square root of n. The t-test is generally used when the population SD is unknown or the sample standard deviation is given. Okay, let's try a given example. It is hypothesized that the cost of making a movie is 24.6 million pesos. This year, a random sample of 15 movies has shown an average production cost of 28.3 million pesos, with a standard deviation of 3.5 million pesos. At 0.01 level of significance, is the hypothesized cost true? So in order for us to know if the hypothesis cost is true, let us start identifying the null hypothesis, alternative hypothesis, sample size, x bar, and s. Okay, let's start. For our null hypothesis, let's start with the parameter. So as you can see, our parameter deals on the hypothesis that the cost of making a movie is 24.6. So therefore, we can say that mu is equal to 24.6. Now, in order for us to identify h of O, we're going to have mu equals 24.6, and h of A will be mu is not equal to 24.6. Now, for your n, for the random sample, we're dealing with 15 movies. So we have 15. And for x bar, this is your sample mean. It is written that your sample mean is 28.3 million. So we have 28.3. And your S is equal to 3.5 million. So we have this one. So we're done with identifying the given values for letter A. For letter B, we're going to identify the type of test. So in order for us to know or to identify the type of test, we're going to take a look on H of A, this one. So H of A deals on not equal. Therefore, we're going to have two-tailed. Just always remember it will be one-tailed if your H sub A or your alternative hypothesis is greater than or less than. Now for your alpha, we have level of significance which is 0.01. Now looking on your t-distribution table, n is equal to 15, therefore your degree of freedom is equal to 14. So you're going to take a look on 14, two-tailed 0.01, we're going to have 2.977. But since it is not equal, we're going to have positive, negative. So now let's plot this on the normal curve. So we have 2.977 negative and positive 2.977. So let's now have the shaded part. It will be shaded here. Okay, now let's now identify the t-value or the computed t-value. So let's now start substituting the given value. So it will be, instead of writing x bar, we're going to have 28.3 minus your mu, which is 24.6, times the square root of n, which is 15, all over your s, which is 3.5. So if you're going to use scientific calculator or any calculator, you can press this one. So double parentheses, 28.3 minus 24.6 close times the square root of 15 close divided by 3.5, you will be able to find the t-value which is equal to 4.09. So now, how are we going to identify the decision? So in making your decision, you're going to plot the computed t-value on your critical region or on your standard normal curve. So positive 4.09 will fall here or here on the rightmost part of the normal curve. So as you can see, since it falls on the rightmost part of the normal curve, it implies that computed p-value falls on the shaded part or shaded region of the normal curve. Since it falls on the shaded region, we can say that we're going to reject the null hypothesis. Just always remember, it will be accept null hypothesis if the computed value falls on the acceptance region or on the unshaded part. Now, how are we going to identify the conclusion, or how are we going to draw conclusion? So let's do this one. So we have claim and result. For claim, let's now check the parameter. We claim based on the parameter mu equals 24.6. So therefore, what we claim on the problem is the null hypothesis, and we never claim the alternative hypothesis. So based, again, how are we going to identify the claim? Let's take a look on the parameter. Based on the parameter mu equals 24.6. Therefore, what we claim is the null hypothesis. Now for the result, since we reject the null hypothesis, therefore, null hypothesis is not correct, and the check is the alternative hypothesis. Now, again, I'm going to repeat. If we accept the null hypothesis, the check is the null hypothesis and the X is alternative. But since we reject the null hypothesis, therefore, check for the alternative cross for null. Since the check, hindi nagtapat yung dalawang check, automatic, the hypothesized cause is not true. Therefore, the conclusion is the hypothesized cause is not true. What if the check meets? If it implies that yung dalawang check nagtapat. Since kapag nagtapat yung dalawang check, it implies that the hypothesized cause is true. However, on our problem, yung dalawang check hindi siya nagtapat. It implies that the hypothesized cause is not true. Let's try another example. The director of a secretarial school believes that its graduates can type more than 75 words per minute. A random sample of 12 graduates has been found to have an average of 77.2 words per minute with a standard deviation of 7.9 words per minute in a typing test. Using the 0.05 level of significance, test the claim of the director. Let's start identifying the parameter. For our parameter, we have average is more than 75 words per minute. So therefore, we have mu is greater than 75. So now, we can now identify H of O. So H of O is always equal. So therefore, we have mu equals 75. H of A, we're going to, or the alternative, we will just simply copy our parameter. We will be having mu is greater than 75. For our random sample, we have 12 graduates. We have n equals 12. So therefore, your DF is equal to 11. For your X bar, your sample mean is 77.2. And your S, or the standard deviation, is 7.9 words, this one. So we're done identifying the important values that we need for computed p-values. So now we're going to identify the type of test. So in identifying the type of test, we're going to take a look on H of A. Since it is greater than, therefore we're dealing with one-tailed. Now for alpha, we can see that our alpha value is 0.05. Now for our critical value, we're going to take a look on our t-distribution table. So on our t-distribution table, we can check the F11, one-tailed, 0.05. So as you can see, the F11, one-tailed 0.05, we have 1.796. So what sign are we going to use? So we're going to use positive. Why? Because our alternative hypothesis is greater than. Take note, if it is greater than, the critical value is positive. If it is less than, the critical value is negative. And if it is not equal, the critical value is positive negative. Now, we have positive 1.796, so it will fall here. And let's now draw the critical region. Okay, now, let's now compute the t-value. Let's now substitute the given value. So instead of writing x bar, we're going to write 77.2 minus your mu, which is 75, times your square root of n, which is 12, divided by your S, which is 7.9. Now, if you're going to press this on your calculator, it will be double parentheses 77.2 minus 75 close times the square root of 12 close divided by 7.9. Now, if we're going to compute for that, your t-value is equal to 0.96. So now, let's now plot 0.96 on our critical region or on our normal curve. 0.96 will fall here. Okay, so 0.96 will fall here, and as you can see, it falls on the unshaded part. Since it falls on the unshaded part, it implies that we're going to accept the null hypothesis. Now, let's now draw or have the analysis. So we have claim and result. For our claim, based on our parameter, we claim mu is greater than 75. Therefore, what we claim is the alternative and we did not claim the null hypothesis. Now, for our result, since we accept the null hypothesis, therefore, null hypothesis is correct and H of A is not correct. Because we accept the null hypothesis, it implies that check for H O, X for HA. Since hindi ulit nagtapat yung dalawang check, it implies that our conclusion is the claim of the director is incorrect. Okay, let's try another example. An anthropologist believes that the diameter of the skull of a primitive man is more than 7 inches. After many years of search, 6 skulls of this type are found. The mean diameter of this is found to be 6.8 inches with a standard deviation of 1.2 inches. Can it be concluded that the anthropologist is correct at the 0.05 level of significance? Let's start identifying the parameter. For this one, our parameter is more than 7 inches. So it implies that it's mu greater than 7. So therefore, we have mu equals 7 for our H of O or null, mu greater than 7 for our alternative, and for N, we have 6 skulls. So therefore, our DF is equal to 5. Now, for your X bar or our sample mean, we have 6.8 inches. And our standard deviation is 1.2 inches. Now, we're done with letter A. Let's now proceed with the second step. We're going to identify the type of test. Since we're dealing with greater than, we have 1 tilde. Now, for alpha, we have 0.05. And for your critical value, take a look on DF, which is equal to 5. 1 tilde and 0.05, we can see that we have 2.015. We're going to use positive since we're dealing with greater than. So let's now have 2.015 and then let's draw the critical region. Now, let's now identify or substitute the given values to the given formula of P. So we have, instead of writing X bar, we're going to have 6.8 minus mu, which is 7, times the square root of N, which is 6, divided by 1.2. So if we're going to press this using your scientific calculator, we have double parenthesis 6.8 minus 7, close, we have times square root of 6, close, divided by 1.2. Now, if we're going to compute that, your computed t-value is negative 0.41. Okay, so we have negative 0.41. Now, let's now plot negative 0.41 on our normal curve. Negative 0.41 will fall here. So as you can see, it falls on the unshaded part. Since it falls on the unshaded part, we can say that we're going to accept the null hypothesis. Now, let's now have the conclusion. Let's have the claim and the result. Okay, so based on our parameter, we claim the alternative hypothesis because mu is greater than 7. Now, for our result, since we accept the null hypothesis, therefore, null hypothesis is checked and H of A is not checked. Since hindi ulit nagtapat yung dalawang check, automatic, we can conclude that the anthropologist or the claim of the anthropologist is incorrect. However, kapag nagtapat yung dalawang check, it implies that the claim of the anthropologist is correct. However, on our problem, yung dalawang check hindi nagtapat, therefore, we can say that the claim of the anthropologist is incorrect. So that's all. Thank you. And please don't forget to subscribe on our channel. Hit the notification bell button so that you will be updated with our video tutorial. And please like our video. So that's all. Thank you and God bless.